Before going on to the question, मुझे एक चीज दिखाना था बस that since we studied about hash code, hash set, so सबके मन में एक क्वेश्चन तो आया ही होगा कि ये नंबर जो जनरेट हो रहा है हैश कोड का, how is it actually working? So the thing with the hash code is कि different libraries have different implementations and different working of hash code, and this is just a simple example I can show you. What happens here is, in simple words, is that string ka a character it picks up and it does some calculation and it does some bit manipulation, left shifts, and then it returns the hash code. This is just a very vague explanation of it. You guys can go and explore for yourselves. आगे बढ़ने से पहले I just thought ये दिखा दूं. Okay, so now we'll move on to the LeetCode question. So today we'll be doing the question number 217, which is the contains duplicate. So first, the problem statement is that given an integer array nums, return true if any value appears twice in the array and return false if every element is distinct. For example, ये हमारा एक array है, nums array, which is 1, 2, 3, 1. And it will return true only if it contains duplicates. As we can see here इधर भी 1 है और इधर भी 1 है, right? So that is why it is returning true. Similarly, for this one, it's 1, 2, 3, 4. As we can see, it does not contain any duplicates, so it is returning false. Here we can see यहाँ पे duplicates है obviously, that is 1, 1, 1, 3, 3. So it has duplicates, so it is returning true. This is a very, very simple question. Okay, यहाँ तक problem statement में किसी को कुछ issue है, right? किसी को कुछ issue है? किसी को समझ में नहीं आया? Okay. Yeah. So let us move on to the constraints part. The constraint we have to concentrate is this one. That is nums.length is in between 1 and 10 to the power 5. So what does this denote? Like 10 to the power 5. मतलब जो हमारा nums array होगा, उसमें हमारा max to max elements कितने हो सकते हैं? 10 to the power 5. And if we look at here, for any computer, it can perform 10 to the power 8 operations easily. 10 to the power 8 operations वो आराम से 1 second में perform कर सकता है. And when we are moving towards solving these questions, the way in which we'll solve these questions, उसके time complexities होंगी, space complexities होंगी. So we specifically focus on the time complexity. So the types of the options we have for the time complexity would be here. Like mostly it would be somewhere here. There are different time complexities as well. So let us take the worst case, which is this one, n square. N square means our n value is 10 to the power 5. And n square means 10 to the power 5 into 10 to the power 5, which is 10 to the power 10 operations. Is this feasible for a computer? It is feasible. Yeah, it is feasible. But it cannot easily perform it within the given time slot, right? It cannot easily perform this within the given within the given seconds. Like it can perform 10 to the power 8 operations per second, but to perform 10 to the power 10 operations, it will require 100 seconds, which is not a good option for us, right? So we'll look at the solution in such a way that हम ये n square वाला complexity ना लाए. Apart from that, we can look at n solutions where we are getting n time complexity and n log n time complexity. So the way we'll move forward with this question is that we'll go from brute, better, and optimal solution, right? यहाँ पे किसी को कुछ doubt हुआ before we move forward? Problem statement, constraints, anything? No, right? Okay. So I hope we understood the fact that why we'll avoid the n square. Okay, but still to understand, to like get into it, so we'll obviously look at the n square solution as well. So starting from the brute force. So like the basic idea जो हमारे मन में आता है when we look at an array. Suppose this is an array, right? So when we look at this array, what is the first thought it comes कि हाँ मतलब हमें we are not concerned about any time complexity, any space complexity. So the basic thought that would come intuitively is that we'll compare. How we'll do that? हम ये एक element उठाएंगे and we'll keep on comparing it with the rest ones, right? First we'll compare it with 4, then we'll compare it with 3, then we'll compare it with 9. Are these two elements the same? Yeah. So we'll return it true, that yeah, this does contain this thus contains duplicates. So I hope ये समझ में आया होगा सबको. But the problem with this solution is that for small array, for small number of for a small size of array, this works fine. Like we'll just keep on comparing. Suppose if this 9 was not here, and suppose if here it was 4, so we'll keep on comparing this one, this one, this one, then we'll keep on comparing this one, this one, this one. So for small arrays, for small size of arrays, we can easily compare it, right? But for larger array, for like 10 to the power 5, ये size के लिए this is not a feasible solution. So we'll move towards the better solution. But before moving forward, let us look at the code for this one. As we understood that we'll most probably we'll pick this element. So the way to pick an element from an array, we'll use one for loop for that. Now we have picked this element. Now we have to keep on comparing with the rest of the elements. So to compare these elements, we'll use another loop. Okay, so we'll use 2 for loops for this, and this will give us n square complexity. So let us look at the code as well. Okay, yeah. So this is just a normal public class, and this is our first brute force ka code, right? This one is our brute force ka code. So first we'll pick the element using this for loop, right? That I goes from I is equal to 0 and it goes till nums.length. This is the for loop to pick the element, to pick the first element. And here we have nums for int j is equal to I plus 1. Obviously, we'll not compare the same element with itself. We'll compare it with the further one. So if we are starting from index 0, we'll compare the index 1, index 2, index 3. That is why it starts from I plus 1 and it goes till nums.length. These 2 for loops. And the condition would be that, as we discussed, if nums of I is equal to nums of j. So when we are comparing index 0 and 1, we'll just check if the element at index 0 is equal to element at index 1. If it's true, then we'll return true. Otherwise, this will never go into this if block, and it will just return false if it does not have any duplicates. So let us run this. It's returning true. So let us visualize this as well. I'll just add a debugger over here and I'll debug. Okay, yeah. So first हमारा main body से ये method call हुआ, right? And it went inside the first for loop. So first for loop पे जाने से it is checking all these things. Like हमारा ये array है, nums array है, and this is our nums.length, which is 9, the size of the array. Okay, so this is अभी ये पहले for loop में गया है, right? And I is equal to 0, the first iteration. So ये I is equal to 0 first iteration हो गया, and it is going inside the second for loop, right? It is here, as you can see. Now, if I go further, it becomes j is equal to 1. Obviously, because j is equal to I plus 1, and I here is 0. So 0 plus 1, j is equal to 1. And now it is going for the if condition. So as you can see from here, the nums of I is 1. That is, the value at the index 0 is 1, and the value at the index 0 is 1, and the value at the index 1 is 3, which is not equal to, like 1 is not equal to 3, right? So will it go inside the if block? No, right? So it will go back to the for loop. See, this condition was not true. So it went back to the for loop. Now it will go for the next iteration. So now j will be equal to 2. Obviously, because j was previously 1, and so yeah. So now it is again checking for the condition. So it is comparing the 0th index and the second index. 0th index is 1 and this is 5. So 1 is not equal to 5. Again, it will not go inside this if block. It will go back to the for loop. See, it went back to the for loop. And again, it will check for the next one. For I is equal to 0 and I is equal to 3. It is checking for the indexes 0 and 3. They are obviously not equal. So it will again go back to the for loop. Here, it went back to the for loop. Again, it's the same. It is now checking the condition as well, 0 and 4. Here, it's 1 is not equal to 6. So again, it will not go inside the if block. It will again go back to the for loop. Again. Okay, and similarly, it will go on until it is until we find a condition, right? Until we find this condition, it will go on. And here, yes. For the iteration where j is equal to 6 and I is equal to 0, we are satisfying this condition. That is, nums of I is equal to nums of j. Where for the index 0 and 6, that means the array has the array in the array, the 0th index and the 6th index have the same values, and that is what we want. So once this condition is satisfied, it will just get inside this for if block, like for which we were waiting. So now it will go inside the if block. It will return true. So once it returns true, it will go back to the main block, right? So yeah, here we can see it's going back till here. So it is printing. Now it will do the printing, and again it will come at the end of the program, and it's printed, as we can see. True. Okay. Any doubts over here? Any doubts? Okay. So let us look at the better approach. Okay. So the better approach would be, first let's check what was wrong here. So we were doing continuous comparisons. So like unnecessary comparisons भी हो रहे थे यहाँ पे. Like when we know कि these things are not, is there like what intuitively comes is that, is there a way to either like keep the duplicates in one place and like उससे efficient comparisons हो सकता है, right? So again, sorry, I'm so sorry I did not cover the time complexity and space complexity. Obviously, the time complexity is n square because we are using 2 for loops, and the space complexity is 1 because we did not use any extra space. Okay, and you guys can go through all of these. So yeah, so the intuition for the better solution would be that, is there an efficient way to like reduce the number of comparisons? Is there an efficient way to like keep the duplicates in one place, and there only we can make less number of comparisons, and we can find if it has duplicates or not? I would say there is. So then comes the better approach, and the better approach would be sorting. So first what we'll do is we'll sort the array. So when we sort the array, we know that if a duplicate occurs, then obviously वो उसके आगे या पीछे होगा, like the duplicates will be like side by side to each other. So it will be easier for us to find out the duplicates. That is the intuition over here. So obviously this is our array. Suppose for an example, so basically if you use arrays.sort, that is a defined function. वो basically वो login time complexity में compare करके दे देगा. So that is why we go for once this is sorted, तो ये हमारा बन जाएगा 1, 1, 2, 12, 60. So this is our sorted array. अभी यहाँ पे तो we do see कि हमें पहले दो ही comparisons पे आ गया. But what if अगर पहले दो comparisons पे नहीं आया? So what we'll do is, so we'll compare these two, we'll compare these two, we'll compare these two, we'll compare these two. So as you can see, loop हमारा एक ही बार चला, and we are just comparing the first element with the second element, and we are moving forward. We are comparing first element with the second element, and we are moving forward. So this is the intuition for the better approach. Let us also look at the code. This was the brute force solution, and this is our better solution. So in the better solution, as we can see, यहाँ पे हम पहले arrays.sort कर रहे हैं. Then we are just running one loop. From I is equal to 0 till nums.length minus 1. Why we are going for nums.length minus 1? Because of this I plus 1. Because automatically only we are just comparing first element with the second element. So when we go for the second last element, वहाँ पे automatically when I is equal to second last element का index. Suppose if I mean, like, let's not take an example. When I'll debug this, तब हमें और अच्छे समझ में आएगा. But yes, so when we are going for the second last element, वहाँ पे जब index will be equal to second last element, so automatically जो उसके बाद वाला element होगा वो यहाँ आ जाएगा. That is why we don't have nums.length. Instead of that, we have nums.length minus 1. Okay, so let us try and run this. Obviously this will return true because यहाँ पे we have duplicates, that is 1 and 1. See, it's true. So let us also debug this. Okay. So as we can see, ये हमारा nums.length and nums array है, and this is our nums.length. अब let's see, ये sorted है क्या? नहीं, right? This is not sorted. This is like the raw array that we gave. So when we move forward, here we can see it's now sorted. Why? Because of this statement, arrays.sort.nums. Because of this statement, now the array is sorted. Obviously we are losing the index, the original index, but we are not concerned about that because we just have to return true or false. Why? Because we just have to like determine if it contains duplicates or not. So we are not concerned about the indexes here. So here, as we can see, now it's sorted. So once it is sorted, normally only we'll just do that I is equal, we'll compare the ith index with the I plus 1 index. So I'll move forward. It will go inside the for loop and it will check for the if condition. So now the I is one, now the I is 0 and the I plus 1 is 1. As we can see here, the 0th index is also 1 and the first index is also 1. So this is true. This is true for just here, like for this example it is true in the first case, but obviously if you take different arrays and different size of arrays and different values, it will be different. Just for example, I've shown you this. So now this condition is satisfied, right? So nums of I is equal to nums of I plus 1. That means the 0th index is equal to the first index. That means the duplicate element is 1. So duplicates exist. That means we just have to return true. So it will go inside the if block. So it went inside the if block and it will return true. Again, it will go to the main block. Here, it's going to the main block and it will go to the end of the program and it will print. Forward to the optimal solution. तो अभी तक जो भैया ने पढ़ाया, जिसके लिए भैया ने इतना पढ़ाया, that is the approach we'll use for the optimal solution, which is the hash set. Okay, so the optimal solution is the hash set. So why we are using hash set? Obviously because it does not contain any duplicates, and जब भी we are looking for elements, right? जब भी we are looking for insertion and searching, it does all of that in big O of 1. So उसका time complexity big O of 1 होता है. Why? Because it uses hashing, hash code, and all those kind of internal working is there. That is why, because of a hash function, because it calculates a mathematical value. जब भी हम एक hash code, जब भी हम एक hash set use करते हैं, जब भी हम एक element उसमें डालते हैं, तो how it works is that उसका एक mathematical function से उसका एक formula derive होता है, and that is unique to that value. So it becomes big O of 1 because of that mathematical formula. So इसीलिए we use hash set, obviously because of duplication and unique elements. Okay, here we can see the example as well, and obviously let us understand this as well. So for example, we have this array 1 2 3 1. We have this array, right? So what we do is हम एक hash set define कर देंगे कि हाँ, we have this hash set. Obviously it will be of integer type because we have integers, and set is equal to new hash set. Okay, so when I create an hash set, what I'll do is I'll keep on comparing the elements. I'll run a for loop over this array, and what I'll do is if the element exists, if the element from the array, if I pick up this element, if this element already exists in the hash set, I will not do anything. I'll just return return true. Why? Because we need that if it contains duplicates or not. So if this value, if this arrays, if the index, I'm so sorry, if the value is already present in the hash set, so we'll just return true, as the question says, if it contains duplicates or not. So what we'll do is, so here we have this hash set, right? So now the hash set is initially empty. So we pick up 1. Does 1 exist in the hash set? No. So what we'll do is I'll just simply add. Does 2 exist? No. I'll just simply add. 3 exists? No. So I'll just simply add. Does 1 exist? Yeah, it does exist. So what we'll do is I'll just return true. Why? Because obviously 1 already exists and we don't want duplicates. So the time complexity here becomes big O of n. Why? Because when we are inserting the elements inside the hash set, that is just big O of 1. As I mentioned, हम एक hash function use करते हैं, mathematical formula and all those things. All of that is done using big O of 1 complexity. And if you guys look into it further, you can explore amortized time complexity, it's a very good topic. You can go and explore for yourself. Yeah. So basically, it's just in simple words, it is big O of one time complexity, and the n comes from this loop. While we are traversing this array, यहाँ से हमें n complexity मिलता है, right? So obviously this is the most efficient solution. This is the most efficient solution, that is 10 to the power 5. A computer can easily perform 10 to the power 8 operations per second, and we are giving it 10 to the power 5 operations. That means obviously this will work very good. But the space complexity here is a little bad, right? But we are not concerned about space complexity. We are concerned about time complexity. So the space complexity also becomes big O of n. Why? Because we are taking a hash set. So what if यहाँ पे तो we had duplicates element. What if an array has all the unique elements? So what we'll keep on doing is कि हम एक element उठाते जाएंगे, and we'll keep on adding it. So in such a way, how many elements we are adding to a new data structure? We are adding n elements. So that becomes big O of n space complexity. Let us look at the code as well. Here it is. Just a second. Again, taking the same array, nums array, and just remove this. This is our optimal solution, right? So first we are creating a simple hash set that is of integer type, and this is an advanced for loop. Obviously सबने कर लिया होगा. So what we are doing is कि we are picking one element from the arrays, and we are checking if this set already contains the value or not. If this contains, if set dot contains will be true, then it will get inside it. If it is false, that means it will not get inside the for loop. So what we'll do is it will not go inside this if block, and we'll just simply add this to the set, to the hash set, right? And then simply we'll keep on doing this. And अगर ये कभी भी इस if block के अंदर गया ही नहीं, that means we do not have any duplicates. So simply we are returning false. Okay. So let us run this. Obviously it will return true because the array does contain duplicates. Okay, so it is returning true. Let us look at the step as well. Okay, yeah. So we are starting with this array, right? And now it is creating the hash set. So now we can see the set is already created and the size is 0, obviously because the set is empty. Now getting inside the for loop. So it is picking the first element. Okay, so the 0th element is 1. Now num is equal to 1. Now it will check if the set contains already, or if the set contains 1. Does it contain 1? Obviously no. Here we can see it is false. It does not contain, so it will not go inside this. Not go inside this if block. It will just execute this set dot add. So it will add the set dot add. Now the set will contain in the next step. Now the set will contain this value 1. Here the size becomes s is equal to 1, and the set contains this value, right? So now again repeat, going inside the for loop, it will check for the next element. Does it contain? Obviously it does not. The 3 is not inside the hash set, so it will add it, right? So this is 0, for this is value 1, and then again when we go to the for loop, it will just show us that it's added here we can see. Here it's there. Integer 3. 1 and 3 are inside the hash set. So now it will check for the next element. So the next element is 5. Is 5 inside the set? Obviously no. So it will add it. Here it's added 1, 3, 5. Now for the next element, 2. Is 2 inside the set? No. So it will add it. As we can see here, 1, 2, 3, 5. Okay. Now again it will go inside the for loop, and again it will check for 6. Is 6 inside the set? No. So it will add it. Okay. Now for num is equal to 7. Is 7 inside the set? No. So it will simply add it. It's added. Now for num is equal to 1. See, for num is equal to 1, it is checking this value. It is checking this statement. If set dot contains num. Set dot contains num. Set dot contains 1. Obviously one is here, one is already here. So what will do? It will not go outside. It will just get inside this if block and it will return true. Right here, it's returning true. Why? Because obviously set. So the num is 1 and it is already inside the set which has a size of 6. Right. So it will return true and it will go back to the main program. Sorry, main block. Yeah, main block here, and it will do the printing and end of the program. Here, it's true. Right.